One second. All right. Good morning, everybody. What's up to my YouTube audience? What's up to all my peeps on Facebook? Now we are beginning again, or restarting the solving of SAT Khan Academy practice problems. It took about like a week and a half hiatus. I've been really, really sick. And then I got better, then I got worse, then I got better. And I lost my voice. That was the biggest issue. And you can see my voice is, it's almost there. I got a little lingering cough, but I'm fine now. My voice is almost there. It's getting better. And so, boom, I'm picking back up with the SAT daily in the morning review. So we're going through, again, a number of practice problems, done a handful of these so far. So we're going to keep it going today. And today we're going to be solving from the systems of linear inequalities practice problems. And again, I'm always doing these problems live. I haven't seen them doing them for the first time. I think in one video I even made a mistake. So it will happen. Hopefully overall that won't happen too frequently. I know stuff pretty well. But anyway, so that's part of the fun. I'm seeing them and I'm solving them live with you guys the first time through. So check these out if you are indeed taking the upcoming SAT. And if you're on Facebook, unfortunately, you won't be able to see my screen share, so you won't see me solve the problems. But if you're watching this and you're like, oh, this is something that I'd be interested in checking out, definitely go to my YouTube channel and you can watch the live stream, or you can watch the video after the fact once it's been recorded. All right, without further ado, it's Mike. Let's get started. All right, so YouTube peoples, let's begin the screen share. And let us begin. So we're going to start by, I'm going to load the problem up here on my trusty whiteboard. And then I'll be a little bit more clear, a little bit clearer. Let's see. Oh, wrong screen share. Here we go. Here we go. Question number 1. K equals blah, blah, blah. So they give us this really intimidating looking formula. In night vision goggles, light rays cause electrons to be projected from a metal surface. The above equation relates kinetic energy, which I assume is our K value right here, in electron volts EV, K of emitted electrons to frequency in hertz V, so this is our frequency, and of incident light rays, and the work function, which is this crazy symbol here, in EV of the metallic surface. I guarantee you this question is not going to be as complicated as it sounds. In a particular set of night vision goggles, the electrons emitted must have a kinetic energy of at least 2.46 whatever electron volts. Is that what it is? Yeah, electron volts. And oh yeah, and kinetic energy, that's the unit of K. If the frequency, so they must have a kinetic energy of at least 2.46 electron volts. If the frequency of incoming light rays is less than frequency, okay, so let me just make sure I understand this right. Light rays cause electrons to be, relates kinetic energy of emitted electrons to the frequency in hertz of incident light rays and the work function. Okay, got it. Which of the following system inequalities best models? And then if the frequency of incoming light rays is less than 9.6 blah blah blah, which of the following system inequalities best models the relationship between the work function and the light source frequency? Actually, this is pretty complicated, but let's do our best here. So first of all, we know that the frequency of incoming light, and our frequency of incoming light, where does it say that? That is the V. So frequency of incoming light is going to be less than 9.6 times 10 to the fourth, right? Because that's what it says. So V has to be less than that. A is saying it's greater than that, so we can cross that out. We're just going to do a little elimination. C is also saying it's greater than that. We can cross that out. Now we're in a much better position. Now we've got to look at these next two. Now, what does it say about the work function? The electron has to be at least, okay, and then it says the electrons emitted, and that's kind of like this function down here. The electrons emitted must have a kinetic energy of at least 2.46 electron volts. And no, wait, so the electron emitted, if the frequency, so we have this guy is, so we got the 2.46 down here. But the question is, and that's our work function. And let me just make sure I understand this work function again. This is what I do when I take these problems for real, is I just kind of really try and study this stuff when the terms get very convoluted. So this is actually a pretty difficult problem. if system inequalities best models the relationship between the work function, and it says light rays and the work function in EV. Oh, it's again in volts, and the work function in electron volts of the metallic thing. Okay, must have a kinetic energy. Oh, okay, got it. All right. So my presumption then in this case is this guy, and then kinetic energy of at least 2.46. So what I think is happening is basically when this guy equals 0, okay. When you know what though? See, now I'm thinking, oh wait, how did I cross this off? Let me see. Is the frequency of incoming light rays is less than 9.6, and that's the incident light rays. Okay, I'm actually not even totally sure on this one. This one's pretty tricky. I'm kind of rolling towards D because it looks like this would be our starting point. This would be our starting constant. It's got to be at least 2.46, but then this part is kind of tripping me up. So I'm honestly not totally sure. Let's go to the explanation. I'm going to go with D, but I'm a little thrown off by this. This is a really confusing one for me. Yeah, it's B. Okay, so what did I have it down to? I had it down to B, and I chose that one. Let's read the explanation. So K must be at least 2.46 electron volts. The expression is this. It's equal to K must be at least 2.6. Oh yeah. See, you know what? I tried to take the work function. I didn't isolate. That's where I got thrown off. See, what they did was they took this entire thing and they set this greater than or equal to 2.46, which is correct. Then they isolated. See, I tried to jump straight into the isolation and make sense of it, or after the fact. So that's where I made the mistake. I didn't get that equation exactly correct the first time. All right. But that is a good lesson. Let's go to the next one. That one was quite convoluted, at least for me. All right, let's go to question number 2. See, I told you I get some wrong sometimes. All right, so let's keep going. So now we've got this guy right here. 651. All right, what does this say? Paper Scrap Inc., a mobile paper shredding and recycling company, receives 39 cents for each pound of paper they shred. But it costs them so they get 39 cents. But it costs them approximately $1.38 per mile. Okay, so this is per pound. I'm going to just write this down here. It costs them, so they get, I'm going to say plus, and it costs them 1.38 per mile to operate their truck. Any job that requires less than 200 miles of travel and also nets at least $500 of profit, less than 200 miles. I'm just putting everything down, but makes at least 500. Okay, greater than or equal to. Qualifies for free delivery. Of the following, which combination of size in pounds and distance in miles would qualify for free delivery? This is a calculated question. Don't have my calculator, so I'm just going to do it without it. And basically what's going to happen is we need to have a $500 profit. And it looks like what's happening is the way we calculate profit, if it's 0.39 times our, pounds. So I'll say P for pounds. Minus 1.38 times M for miles has to be, and then for free delivery, it has to be greater than or equal to 500. So this is the inequality. And we also know, I mean, if you actually want to get the system of inequalities, the second one is it also has to be, let's see, the job has to require, it has to be less than 200 miles. So our miles also has to be less than 200. Okay, so now if we look at this, let's just make sure, first of all, right off the bat, let's cross off D. This is 225 miles. That's crazy. That's too big. Now let's look at these other answers. So now we've got 3 miles of travel. So let's see, 3 miles of travel and let's make sure we're not missing anything else. If we have 3 miles of travel, I can approximate this really quickly. And that's about $4. So this would be like minus $4. And then we've got 1100. Let's just pretend it's 1,000. 1,000 times is 1, 2, 3, so it's 390. So this wouldn't actually hit that, right? Because I did 1100 and you get, yeah, this wouldn't actually make that 500 profit level. Let's go to this one and let's try this guy. 1,500. Now this one, because this is going to make less money than this. So it's probably going to be, this is probably going to be C. So let's do 1,800. I'm going to actually multiply this out. 1,800 times 0.39. Let's just say 0.40. Okay. 0, 0, 2, 3, 4, 7. And, oh yeah, sorry, 0.4 is just one decimal. So it's 720 minus 94 times 138. Let's again do 1.4 because I gotta approximate because I don't have a calculator here. Save time, 16, 37, 0, 4, 9. So that's about 12, 13 bucks. I'm sorry, 130. It's about minus 130. So that's going to be it because this is going to be over 500. That's all we were trying to do is figure this guy. So we can definitely go with C because, right, maybe it's B too, but I doubt it, right? Because it has to be, this is going to make more money. So let's go ahead and make sure we're right here. So we'd say, okay, C qualifies and boom, we are good. Okay, let's see the time. Gotta go. Oh my gosh. All right, I actually probably can do one more. Let me copy this and move it over. All right, let's take this guy down here. Let's go. When Siraj goes to Royce Field Golf Course, he loses 20% of the golf balls he uses when he goes to, so he loses negative. I'm just going to say he loses 20% at Royce Field. Here he loses 30% at 100. It costs him $1.20 to buy a ball. This weekend, Siraj is planning to use 25 balls at Royce Field and 30 balls at Huntington. If he has only $20 to spend, how many balls can he buy in order to guarantee that he will be able to replace the balls he loses? So what, $20 to spend on balls? Okay, so he's using 25 at Royce Field. I mean, this one, I don't even have to set up inequalities. I think I can figure this out. So he's using 25 at Royce Field, and if he loses 20% of those, that's just 5. So he loses 5 balls at Royce Field. And if he's bringing 30 balls to Huntington, he loses 9 balls at Huntington. And how many balls can he buy in order to guarantee he'll be able to replace the balls? Okay, wait, let me just make sure it costs Siraj $1.20 to buy a ball. So this week, Siraj is planning to use 25 balls at Royce Field and 30 balls at Huntington. And if he only has $20 and it costs $1.20 ball in order to guarantee that he'll be able to replace the balls he uses. So he's going to lose 14 balls. So he needs to buy 15 balls. He can't even buy 20 balls. 15, let's just make sure he can afford. Yeah, because that costs $8, $18. So it's going to be C. I hope that makes sense. The way that I calculated this was I was like, all right, if he loses 20% of 25, I just did it mentally, but you could say we take 0.2 times 25, and it ends up being 5. All right, it's just like 1/5 of 25. And then the way I did 30% of 30 is, again, you turn into a decimal 0.3 times 30, and you end up getting 9. Again, you could use your calculator for this. I just chose not to, but that's the fast way. That's how I got this 9 and 5 balls that he would lose. Combine them and he would lose 14. He has to buy 15 to make sure to replace everything. So let's go back here and we'll just make sure we're right. What we're going to do is today we're just going to split this up, and I'll solve these last 2 tomorrow. I'm going to leave it open on my computer. And tomorrow when we get started in the morning, I'll solve these. And then maybe if I have time, I'll do one more section. But anyways, I'm back, guys. And here, let me get back here on YouTube too. No more screen share. Oh, wait. Stop sharing. Okay, so anyways, good morning, and thank you guys again for joining me. I'm gonna get back to getting ready because I gotta get to school pretty soon. Actually, gotta leave in like 5 or 10 minutes. And that was really fun. So we will keep it going. I'm gonna keep up with these SAT Khan Academy practice problems to give you guys as much insight and help as possible. We'll go from there. Thank you guys so much for joining, and have a great day.